Welcome to Educare 247. In this video, we are going to discuss the second concept of a CAT Concept Express series, which is method of differences. Trust me, this is a very unique concept which is often repeated in premier examinations like XAT, CAT, IIFT and all other MBA entrance examinations for that matter. Alright, so you would not want to miss out on easy marks. It's a very easy concept, but most of the students are not aware about it as they are not aware only about it. So as the name suggests of the series, CAT Concept Express series, we are going to bring you such unique concepts. So let us see this unique concept of method of differences now. So first and foremost thing, this concept is based on spatial series. Spatial series in sequences and series. Alright. So what is a spatial series? Series in which difference in its successive terms is in AP or GP and there is no specific pattern, then it can be solved using the method of differences which I called as MOD. Alright, so for example, I'll just show you what the spatial series means. 5 plus 7 plus 11 plus 17 plus 25 up till Tn. So you can see if the summation of this series is asked, there's nothing over here that you can make out. No specific pattern is there, right? From 5 you go to 7, from 7 you go to 11, alright? So there is a difference of 2, 4, 6, alright? And here it's 8. So you can see that the difference is in AP. There is a gradual increase of plus 2, right? So this is a spatial series. Similarly over here, if you see 1, 3, 6, 10 and 15, you cannot find any pattern over here. But if you see, if you take the difference between the successive terms, it is 2 over here, it is 3 over here, alright, it is 4 over here, it is 5 over here. So plus 1, plus 1, plus 1. So this is also in AP. The difference between the successive terms is in AP over here. So such series are called spatial series and method of difference is applicable for them. So now that we understand what is a spatial series, let's see how we can solve it by using the method of differences. So we have asked, the spatial series has been given to us and we have been asked the summation of that spatial series. How will we solve? So let's suppose S is equals to A1 plus A2 plus A3 up till Tn minus 1 plus Tn plus 1. So this is the second last term and this is the last term, right? What you will do is you'll write this Sn, the sum of n terms, as it is below the first line, alright, below this series. But now you'll just make an exception. You'll just shift it one element ahead. So you'll write A1 over here, A2 over here, similarly A3 over here, alright, if A4 is over here, and so on. Alright, so what happens is your Tn minus 1 will be over here and your Tn will be over here at the end, right? Now the next step what you'll do is you'll take the difference of, suppose this is equation 1 and equation 2, take the difference of both the equations. What you get over here is 0, right? A1, here it is A2 minus A1, right? Here it is A3 minus A2, right? Plus A4 minus A3 and so on. And at the last you have Tn minus 1, right? Minus Tn. Alright, so this is what you get after subtracting equation 1 and 2. Now, excluding this first element and the Tn, that is the last element, this complete expression, this will now be in AP. Why? Because AP or GP, whatever it is, the successive difference between the terms, right? This is A1. So, since this is in AP, we can find the sum of the terms over here, whatever these terms are. And the total number of terms over here are n minus 1. Hence, this we can find out by using the formula of sum of n terms, right? Rest everything remains as it is. This A1 will stay at this place and this Tn will bring it on the left hand side. So now we have this Tn is equals to A1 plus this A2 minus A1 plus A3 minus A2, right? Plus A4 minus A3 and so on up till Tn minus 1, right? Which is basically nothing but sum of n terms, right? So this is not job full done. You have just found the nth term, right? Tnth term, which is the last term. Now we need to find out the summation of this. So we need to find out the summation of Tn. So it will completely be the summation of all of these terms inside the bracket. So now you should know the rules of taking the summation, alright? So I'll show you what are the rules for taking the summation, right? So if you take a summation of say n equal to 1 to n, and inside there is just n. So sum of first n natural numbers will be n into n plus 1 divided by 2, right? If you take a summation of n square, right, what will be the formula? It will be n into n plus 1 into 2n plus 1 divided by 6. Now if I take a summation of cube, alright, from n equal to 1 to n equal to n, what will be the formula? It would be n into n plus 1 divided by 2 whole square, alright. And last, if I take a summation of a constant number, alright, if I take a summation of a constant number, so let's suppose it is c. So summation of c, which is a constant number, will be cn. Alright, always keep this in mind. So this will be helpful to you when we solve the question. Let us now see an example on this type. Let us now have a look at this question. Sum of the series 1 plus 5 plus 12 plus 22 plus 35 up to n terms is. Alright, so if you can observe, this is a special series because you cannot find any specific pattern. But if you take the difference, you'll have the difference as 4, alright, 7, here 10, and here you will have 13. So you can observe this is plus 3 and plus 3. So this is an AP with a common difference of plus 3, right? So we know that this is a special series and hence can be solved with method of differences, right? So let's get started. First and foremost thing, write it in the form of Sn. Sum of n terms is equals to 1 plus 5 plus 12 plus 22 35, alright, tn minus 1, which is the second last term, and tn, which is the last term, right? We will write as it is Sn over here and just shift one element to the right side, right? So 1 plus 5 plus 12 plus 22 plus 35, right? And here you will have tn minus 1 plus tn, alright? Now we take the difference of both the equations. What you have here, Sn and Sn gets cancelled, so 0. In this 1 comes down. 5 minus 1 is 4, right? We'll take this as a complete different series. 12 minus 5 is 7. 22 minus 12 is 10. 35 minus 20 is 13, alright? And so on. So this goes on till tn minus 1, right? And this tn is left at the end. Alright, so we'll bring this tn on the left hand side. So tn is equals to 1 plus this AP that has been formed over here. What AP? 4 plus 7 plus 10 plus 13 up till tn is tn minus 1. So this is an AP with n minus 1 terms with a common difference of 3, right? But if you closely observe, even this 1 can be included in this series because the common difference is constant. So we will have a series of n terms properly, right? So this will be, if we rearrange 1 plus 4 plus 7 plus 10 plus 13, alright, up till tn minus 1 term, alright. Now sum of n terms of an AP, alright, Sn. I hope you are aware about the formula. If you are not, I will show you over here. Sn is equals to n by 2 bracket 2a plus n minus 1 into d, right? Where n is the number of terms, alright, a is the first term and d is the common difference, alright. So placing the values over here, we'll get the sum of this series that we are having over here, right? So what will it be? It will be n by 2, right? Because there are n total terms. 2a, so first term is 1, so 2 plus n minus 1, it will remain as it is, into 3 because the common difference is 3, right? So in the end you have 3 by 2 n square minus n by 2, right? So this is the value of nth term, right? Now since we have got the value of nth term, we'll have to find the summation because we need the sum of all the n terms, right? So we'll take summation on both the sides, right? So if we take the summation on both the sides, what will you have? So you'll have summation, this 3 by 2 comes outside and this n square, minus 1 by 2 comes outside and this summation n over here, correct? So this is summation tn. So this is 3 by 2. What is the summation of first n square natural numbers? We had seen the formula, it is n into n plus 1, 2n plus 1 divided by 6, and here 1 by 2, and sum of first and natural numbers was n into n plus 1 divided by 2, right? Here these 3 ones are 3 twos are correct. So we have n into n plus 1, 2n plus 1 divided by 4 minus n into n plus 1 divided by 4. So what we can take out common over here? We can take out n into n plus 1 divided by 4 as common, and what is left inside? It is 2n plus 1, alright, minus 1. So this 1 gets cancelled. 4 2 ones are 2 twos are. So what we are left with is n into n plus 1 divided by 2 into n, right? So the final expression is 1 by 2 n square into n plus 1, and this is your answer. Alright, so what is the value of Sn? Sum of n terms of the series that we were supposed to find out. The value of the sum of n terms of the series that we were supposed to find out was n square into n plus 1 divided by 2. This is your final answer. Alright, you'll feel this overwhelming at first, but trust me, once you practice 3 to 4 problems, this will be a piece of cake for you, and this is a very important problem for CAT, XAT and all other premier MBA entrance examination. So I hope guys you enjoyed the concept and the question that we have taken, and it definitely will help you. Thank you and happy learning.